Hi, my name is Daniel Kim, and this is my project presentation for ITM315. I chose a small company in East Bay that is typical of many companies that I have worked with. I have often worked with small and mid-sized companies that have started with a small network closet, but eventually outgrew their initial IT service setup. This is what happens eventually. An entire IT infrastructure will be shoved into a small room or in a wiring closet. These setups are often created as an afterthought, and they are disasters waiting to happen because of their messy cabling, lack of redundancies, lack of planning, lack of proper cooling, lack of securities, etc. etc. We want to go from this to something like this or something like this. This project will attempt to address the typical small and mid-sized organizations that need a proper data center after outgrowing their current ad hoc setup. I have chosen a small company that provides software as a service and has less than 30 employees. They rent an entire floor of an office building, and due to their lack of space, the data center needs to be allocated inside and designed to be a maximum of 1,000 square feet. This is the office building. This organization currently runs only 20 servers as of now, but is finding itself growing rapidly and is adding about 2 servers a month. It is expected to grow at this pace for at least 2 months. Two few years. Most servers are 2U in size, and there aren't any odd-sized or extremely large equipment. Future servers are expected to become smaller and more power efficient. The CTO desires to have at least 20 racks to accommodate for future growth. Although the SaaS applications run 24/7, majority of the usage and network traffic occurs during the business hours. Internally, network runs on 1 gigabits and 10 gigabits per second, and the company has fiber optics connected to an ISP. Currently, uptime of 99.9% is satisfactory, and there are 2 full-time IT personnel dedicated for the data center, but more will be hired as needed. This is the floor plan of the entire floor. For 20 racks, a data center will fit well under 1,000 square feet. Since the data center is located within the office space of a multi-story building, it will have some restrictions as to its location. While the office building has windows, the data center should ideally have no windows and only a single point of entry. Therefore, the data center will be sealed off as a separate room with walls that extend from floor to ceiling and have no other accessibility except for the main entrance. The data center is located as far away as possible from the kitchen and other common areas to avoid EMI and from microwave ovens, and from also to minimize traffic of people passing by the data center. It's also good to be located away from the restroom and avoid any plumbing infrastructures. Unfortunately, this was not possible since the restroom was located right in the middle. Also, the data center was designed to be rectangular in shape for optimal layout. A separate storage and supply room was also created near the data center. That room will have all the inventories of unused servers, networking equipment, tools, patch cables, and other supplies. This is the layout of the data center itself. Within the data center, there are 3 separate rooms. Immediately upon entering the data center through the main entrances, the UPS and its batteries will be accessible. There are 2 pairs of UPS and battery for redundancy. Further in, there is a networking room where all the networking wiring terminates. It houses all major network equipment such as the router, switches, and patch panels, as well as the fire suppression unit. This section should be less than 100 square feet. The other room is the control room where the IT personnel can monitor and control the data center. Control room should be about 200 square feet. Once inside the control room, the main room of the data center is accessible through the secure controlled door. Inside the main room, all the racks and the servers can be installed, serviced, and maintained. The main room should be about 600 square feet in size. The overhead installation was chosen over the raised floor installation because it was a better fit for the small data center and had benefit of lower installation costs and less complexity. As a result, structured cabling are installed above, supported and routed by ladder racks. Power receptacles are housed in metal raceway and secured from the ceiling and suspended from the above. Also, there are overhead duct returning on the ceiling to draw the hot air from the from the hot aisle. Even though the racks are not fully populated, all cables are pre-wired for future installation. Since the data center is rather small, the electric conduits run from PDU directly to each server row via direct connect power. For redundancy, there are two sources of electric power, routed through two PDUs. Each PDU runs at 50% capacity, and each rack has two power strips, each connected to separate PDU. Power cables are routed through the flexible conduits, or whips. There are two air handlers for redundancy. Each are running at 50% capacity and can take over the entire load if one were to fail. EPO switch is also located as soon as one enters the control room. As regarding the power, it is estimated that each rack is rated at 2.4 kilovolt amp, and with the 20 racks total, there are about 48 kilovolt amp rating, and the entire power for the data center should draw around 40 kilowatt. Using the data center efficiency calculator found here, I expect a PUE of over 2 and annual costs of electricity over $44,000. Given the 600 to 800 square foot space and full load of 40 kilowatt, the cooling requirements is about 11.4 tons. The Word document has more information and detailed calculation on this. Each air handler has about 20-ton capacity, so a single air handler should be sufficient for the entire cooling. However, as redundancy and as a backup, I added a second air handler. So how much does this setup cost to build? Using this calculator, which David also used, I found the total capital cost for about $430,000. With the redundant system in place, it will cost more, about 20% more at $581,000. The CFO has also indicated that in the following years, the company expects profit of $200,000, in the second year $300,000, and in the third year $450,000. The ROI for the data center should be about 25% in the first year, and payback period is about 2.3 years, which is pretty good. I chose solar panel as an option for green system because it is not only a clean energy, but also a potential of significant savings of energy cost is possible. Installing solar panel is a good consideration for this company since there is an availability of roof space on the building, which can be leased from the landlord, and there are plenty of sun in the East Bay area throughout the year. There is about 4,000 square foot of space on the roof where solar panels could be installed, while the other spaces are taken by cooling towers, building HVAC system, and other utilities. These photos are taken from actual data center in New York, and they also have a similar setup. On the roof, they have installed as many solar panels as they could. Using this online calculator, about 20% of electric power could be provided by the solar panel when using about 4,000 square foot of space and about 250 solar panels at the cost of about $170,000 after tax. With the redundant system and green options of solar grids, the total cost becomes about $750,000 and increases the cost by almost 30%. When calculating the ROI, there is also consideration of benefit of cost of energy savings of about 20% or about $9,000 annually. We can see that green option ROI will be smaller, but the differences is not big enough to justify not using it. The overall payback occurs in 2.68 years. We also gain the benefit of perpetual energy savings. There are many risks for this data center. The goal of achieving 99.9% availability requires that there is no more than 8 hours and 45 minutes of downtime during the year. Therefore, it is absolutely necessary for redundancy in this design, and not having redundancy, it would be impossible to achieve that goal. There are risks of power failures, and this is addressed by having generators and redundant UPSs. Two separate and independent PDUs provide redundancies and power source. There are two separate air handlers, and redundant cooling system provide redundancy to mitigate the risk of cooling failures. Since the data center shares the same office space with other employees, there are risks of security breach and other interferences. Anyone in the office can simply walk by the data center even by accident. In order to mitigate the danger of security breach, there is a single entry. Each entry point is secured using locked doors and accessible only through valid badge access. proper access policies and procedures are implemented and reviewed periodically to improve security. Security cameras are placed within the facility to deter and detect intruders. Finally, there is the risk of having to relocate the data center in the future. By having a data center in a leased office space, there's always the possibility of loss of lease in the future if the landlord decides not to renew the lease, forcing the company to relocate. Therefore, a long-term and guaranteed lease is a prerequisite before data center is implemented. There's also the possibility that the small-sized data center will limit the growth in the future when they run out of space for new IT equipment and eventually force the company to unnecessary relocation. However, high-quality forecasts of IT growth and reassurance from the CIO and the CTO have validated the size and location of the data center. Thank you very much, and I hope this was an informative presentation.